All right, I was asked about question number 14 from the MyLab-Math. And this is one of those situations where I kind of wish I would have done all the problems ahead of time, because this does require a partial fraction that we haven't really talked about yet. So I'm going to present it anyway, and if you follow along, great. If not, know that it's not going to be on the test. And I'm actually going to show you a couple different partial fractions in here just so you can see them. Okay. This problem actually asked you to take the integral of 289 over x cubed minus 17x squared dx. And there are a few things we could do to rewrite this initially. I mean, if you want to pull out the 289, so we're just dealing with a numerator of 1, that would be fine. Also, I'm going to factor this denominator to look like this. Now, this is a partial fraction, but the problem is when we have a repeated factor. Remember I told you that AP does not do repeating factors on theirs, and this is why. So this happens to be a repeating factor, and that's the problem. So when we set up this integral, when we set up this partial fraction, we need to think about it as x times x times x minus 17, because they all need to be linear factors. Now, the problem is the number of factors that I have repeated means I have to address those a little bit differently when I go to set up my linear terms. So I'm going to ignore this part for just a second, and I'm going to go just to the partial fraction piece. Okay, when I set up my partial fraction, I will do a over x plus I will do b, but I'm not going to do it over x, I'm going to do it over x squared. And I understand that that is not, we don't have an x and an x squared and an x minus 17, which is what I'm going to do next. But a repeated root requires this step. So our original problem was x squared, but I have to have each term before it. So for example, just as a side note, if my denominator had been something like 1, let's do pencil, 1 over x plus 2 times x plus 2 times x plus 2, our breakdown would be a over x plus 2 plus b over x plus 2 squared plus c over x, well, it actually wouldn't be b and c, it'd be bx and cx, but this would be cx squared plus, anyway, we would have to include all of those terms in there. So that gets a little bit messy, and so don't worry about that. AP will not focus on repeated roots. Okay, so in this situation, I do need to include the repeated root and what I originally started with. And just like with partial fractions, the way we've done it every time is multiplied the entire thing by the common denominator. Okay, so what that gives me is 1 equals a, but a is going to be multiplied by x and x minus 17. B is only going to be multiplied by x minus 17, and c is going to be multiplied just by the x squared. Okay, now this one gets a little bit messier to try to set up to use Heaviside method. Using Heaviside method can get a little bit messy, but we know there's two zeroing things. There's two things that work. So if we let x equals 0, then we get 1 equals, it would be a times 0, so that goes away. B times negative 17, and then the c would be times 0. And so then we'd get b equals negative 1/17. And then if we let x equal 17, when I substitute in 17, I get 1 equals, a would still go to 0, b would go to 0, and then I would have c times 17 squared, or c equals 1 over 289. Now here's the problem. I need an a, a b, and a c. The problem is I need to solve for those. And since I already have values for b and c, I really can pick any other x values and plug them in and create another system that will allow me to solve this. The x values I choose are not really that important, so we want to pick smaller x values that we can solve. Okay, so if I say, for example, let's let x equal, I don't know, maybe 1. Then I get 1 equals a times 1. I think it's a lose-lose at this point. A equals 1 times 1 minus 17 plus negative 1/17 1 minus 17. There probably is a more strategic one I could pick. Plus c is 1 over 289. C, that's c, x would be 1 squared. Okay, so notice all I have now is to solve for that a value. And as long as 1 is in my domain, we should be okay. This creates negative 16a equals 1 minus plus 16/17 plus 1 over 289. This is fun. Okay, I'm going to cheat and use my calculator here. So if we do 1 minus 16/17 minus 1 over 289. Oh, and let's change that to a fraction. Oopsies, what just happened? Change that to a fraction. I get negative 16a equals 16 over 289. And I'm going to divide by negative 16. And when I divide that answer by negative 16, I get a equals negative 1 over 289. Lovely, right? Okay, so, oh darn, none of these are grouped. Let's group those so I can make it smaller and scoot it up. Okay, so now I have the integral. What I will be doing for this particular problem is the integral of negative 1 over 289 over x. Don't lose the 289, that was already out there. Plus the integral 289 times the integral of b, where's b? Negative 1/17 over x squared dx, lost the dx here, plus 289 times the integral of c, which is 1 over 289 over x minus 17. Now, the beauty of this is this one just gives me negative the integral of 1 over x dx. This one, if I divide 289 by 17, we get 17, so I really just have plus 17 times, or it'd be negative, but negative, let's go change that. This would be negative 17 1 over x squared, plus that goes away, so that would be the integral of 1 over x minus 17. And so therefore, we get, this would be negative natural log of the absolute value of x. This would be minus 17, but I'm going to go up a degree and divide by that degree, which would be negative 1, so it's actually going to turn positive. And this would be the natural log, or 17 over x, plus this one will be the natural log, the absolute value of x minus 17, plus c. So no, you will not have a question like this on your test. That does have repeated roots in there, and the AP is pretty adamant that they will not do repeated roots for partial fractions. So pretty cool thing to look at, but not necessary to know. So hopefully that helps. Question number 14 on MyMathLab Unit 5 review.